So quadratic functions, right? They are the graph of a parabola. So the graph either opens up or it opens down. And actually they can open sideways also. In this class though, we only focus on the ones that open up or down. The standard form for a quadratic function is y equals ax squared plus bx plus c, right? Where a, b, and c have to be real numbers. The parent function for quadratic functions is just y equals x squared, where the value of a is 1 and b and c are both 0. All right, and you can see that graph right here is the graph of y equals x squared, the parent function. So everything we've been working on the last few days with these is basically we've done transformations of them. We've moved them around left and right, up and down by moving the vertex, basically. And then we also looked at them getting narrower and wider. Okay? So the main thing to think about with the quadratic function is that if I made a table of values, like 0, 1, 2, 3, 4 with my x values, that my y values or them are just squares. So when you're thinking about quadratic functions, you're really just thinking about some variation of those squared numbers and what happens to them. But for it to be a quadratic function, it has to have an x squared term. So the highest power has to be 2. So we talked about these graphs being parabolas and the fact that the graphs either open up or down, and we talked about why. Now, first of all, they've always got to be in standard form like this, like we just talked about. They have to be in the form y equals ax squared plus bx plus c before you can tell whether the graph opens up or down, or before you graph it, or before you find the vertex or the axis symmetry. We want it to be in this form all the time. So if it's not in that form, then you're going to rewrite it in that form. Okay? If it doesn't have a squared term, then it's not a parabola or a quadratic function. Right? It must have a squared term. If a is 0, though, okay, what do I get when I multiply by 0? 0. So if a happened to be 0, then it would not be a quadratic. It would end up being a linear model then instead. Okay? All right. So we know that when a is positive, it opens up, because what happens when you are feeling positive? What do you do? What do you do when you're feeling positive? You smile. Okay? And when you smile, you make a parabola that opens up. And when you're feeling negative, you frown, and then we get a parabola that opens down then. Okay? So when a is positive, it opens up. When a is negative, it opens down. And this is very important because all quadratic functions have a min or a max. And to know whether you have a min or a max depends on whether you are smiling or frowning. Okay? And so you need to understand that. So when it comes to graphing, you need to have an idea of what it's going to look like before you actually make it a graph. All right? So here we go. I'll give you 2 more chances on these. All right? Tell whether each graph or each quadratic function opens upward or downward. All right? Upward or down. Okay, so when you are doing these, make sure that it's in the form y equals ax squared plus bx plus c before you determine whether it opens up or down. Okay? So letter A here, it's not just y equals. All right? It's y minus 1/4 x squared. So we have to add 1/4 x squared to both sides first. So y equals 1/4 x squared plus x minus 3. So what is the value of A then, Blake? What's the value of A?
What do you mean, Blake?
What's the value of A? Okay, it's 1/4. So A equals 1/4. Since that's a positive number, it's greater than 0, then it opens up. Okay. All right, letter B. Once again, we need to make sure it's in that form. So we just rewrite it. So negative 3x squared plus 5x. All right, and A is always the coefficient of x squared. So in this case, A equals what? Negative 3, which is less than 0. So this opens down. All right, so make sure you are clear about that. So it's got to be written y equals for you to determine that. Okay. All right. The highest or lowest point on the parabola is called the vertex. All right. The vertex has an x-coordinate and a y-coordinate because it's an actual point. Now, depending on whether it opens up or opens down, depends on whether you have a maximum or a minimum. So if it opens down, we have a minimum because it comes down and then goes back up. And if it opens down, it has a maximum because it goes up and comes back down. So we've talked about these already. All right, so here is 2 more graphs. Identify the vertex and then tell the min or max value. Okay. All right, so letter A. What's the vertex then, Sammy? Now there's an x-coordinate, it's a point. So what is the coordinates of this point? Okay, negative 3, positive 2. All right, so is that a maximum or a minimum? So it's at the bottom, right? So if it's at the bottom, that means it's a minimum. So this has a minimum at the y value of 2, all right? So these two numbers always go together, okay? Now the other thing is it will continue this, there's this thing called the axis of symmetry, right? We talked about that a little bit. The axis of symmetry is what cuts the graph in half vertically, okay? So that means there's actually a vertical line. You can't see it, but there's a vertical line here that cuts the graph in half. And it goes through the vertex, and it specifically goes with which part of the vertex? Okay. You did this a little bit yesterday, but what is it? It goes through the vertex, so the axis of symmetry in this case is x equals negative 3. All right. So with the vertex, the x value is the value for the axis of symmetry. The y value is the value for the min or the max. Okay. All right, so letter B, our vertex here is at the point 2, 5. So it has a maximum at 5. And the axis of symmetry, which I'm adding that in, all right, would be x equals, and it's a line, okay? The axis of symmetry is a line, so it's always going to be, for your benefit, an x equals line, and it's always the x value for the vertex. So x equals 2. So there's a imaginary line, you can't see it, that runs through the vertex, vertical line that runs through the vertex because it cuts the graph in half. So they are the two sides of that are mirror images of each other. Okay? Okay? All right, so with that in mind, here's two more graphs. I want to know what is the axis of symmetry for those two graphs. Okay? All right, so we've opened up or down if A is positive or negative. The vertex is where the graph changes directions. All right, so it's either the top or the bottom of the graph. And that part is also a max or a min, and which is the y value for the vertex. And the x value for the vertex then tells us the axis of symmetry. Now, if we don't have a graph, but we have a function in standard form, then we can find the axis of symmetry by doing negative b over 2a. Right? So when it's in standard form of y equals ax squared plus bx plus c, we find the axis of symmetry by doing x equals negative b over 2a, which you worked on yesterday. Okay? Make sure that you have x equals. All right? So you worked on that. So, okay, here we go. Number 3 here, find the axis of symmetry for that graph. All right? So what is that axis of symmetry? So when you're doing these, make sure that you're identifying one of the things you should do is identify A, B, and C to start with to help you, because that'll help you also when we start graphing them. Okay? So A is negative 3, B is 10, C is 9. All right? They all have their purpose. So to find that axis of symmetry, x equals negative b over 2a. So we have the negative sign, 10 goes in the numerator, 2 times negative 3 in the denominator. So this is negative 10 over negative 6. And then we're going to leave it as a fraction in simplified form, or lowest term. So this is 5/3. So my axis of symmetry is x equals 5/3. Don't forget the x equals, right? Because it is a line. Even though when we graph parabolas, we don't graph that line, it's still there to remind us that it cuts the graph in half. Okay? All right, axis of symmetry. Now, we use the axis of symmetry then to find the vertex. Were you doing the other one? All right, here, go ahead and do that one. So when they ask us to find the vertex when it's in standard form, the first thing we have to do, all right, is we have to find the axis of symmetry. All right? And we're going to talk about zeros too. It says to find the x-coordinate of the vertex, find the axis of symmetry by using zeros of the formula. Okay, we're going to talk about the zeros in a little bit, but we're talking about the formula right now. To find the y value then, what do we do with the x value? Okay, we substitute it in for x. All right, and then we write it as an ordered pair. So we find the x-coordinate of the vertex by doing x equals negative b over 2a. To find the y value of the vertex, we plug it in then. All right. Now, sometimes if they give us a graph, hopefully you can find the vertex without doing any calculations, right? All right, so we know that here our vertex is this point down here, all right, which is at negative 1, 2, 3, 4, and negative 1. So the vertex here is at negative 4, negative 1. Definitely wasn't a water beverage, Jack. All right. Notice one thing. We're going to talk about zeros a little bit more in a minute. Okay. But zeros are where the graph crosses the x-axis. And you can see here that this has zeros at negative 2 and negative 6. And the vertex, the x value for the vertex, happens to be halfway between them. Okay. All right. So we want to find the vertex for this function. So the first thing we have to do is find the x-coordinate for the vertex, which is just doing the axis of symmetry. So first I'm going to identify A, B, and C. A, -3. B is 6. C equals -7. All right, so I'm very clear what they are. And remember, it's got to be in standard form. Y equals ax squared plus bx plus c. All right, so x equals the opposite of b over 2 times a. So the opposite of 6 over 2 times -3. So this is -6 over -6, which equals 1. Okay? So the x value for my vertex is +1. So to find the y value then, I'm going to replace all of those x values in the equation with that number. Now, one of the things that I see happen quite often, you have to be careful, is that lots of people want to square this -3. It's not squared, okay? The 1 is squared. Remember your order of operations, okay? Or they'll multiply the -3 times 1 and then they'll square it, all right? Remember order of operations. So this is -3 plus 6 minus 7. So 3 minus 7 is -4. So my vertex is the point 1, -4. All right? So x equals 1 would be the axis of symmetry, and -4 would be my max value, right? Because this one opens down because a is negative. All right? So if I needed that information, I have it. So you need to be prepared to have a question like this to where I ask for the axis of symmetry, ask for the max value or min value, and the vertex. So you need to be able to do all of them. All right, so here's another one. Y equals x squared minus 4x minus 10. Find the vertex. Okay, the next thing is domain and range of a quadratic function. Domain and range. If you remember from your past math classes, when we talk about domain, we talk about what happens horizontally, or the x values. When we talk about range, we talk about what's happening vertically, or the y values. So for a quadratic function, the domain is always, okay, all real numbers. Okay? If it's a quadratic function, it's all real numbers for the domain. Because if you follow the graph from left to right, it never stops, it never breaks, there's never any holes. Okay? It's just a nice smooth curve moving from left to right. So the domain is always going to be all real numbers. The range is completely determined by the max or the min. Right? So if it has a min, then the range is all the numbers above the min value. If it has a max, then the range is all the numbers below the max value. So this graph they have right here, the vertex is the point 2, 1. So it has a minimum, so all the y values are everything greater than or equal to that value there. So we would say the range is greater than or equal to +1, which was the y value for the vertex. All right, so y value for the vertex, not only does it tell us the min or max, it also tells us the value we need for range. All right, so here we have this graph. All right. The domain, and you can write domain this way when we talk about all real numbers. All right, it's this symbol here. It looks like the paragraph sign that your English teachers would use, but it's actually an R then for all real numbers. Okay, this means all real numbers is that paragraph sign, but as an R. All real numbers. Okay. The range Since this graph has a max, then the range is going to be y is less than or equal to, and the y value for the vertex is -1, 2, 3. So we say y is less than or equal to -3. So this vertex here of 5, -3, we've added one more thing to that. Okay? The 5 is the axis of symmetry. The -3 tells us the min or max value, but it also tells us the y value then for the range. Right? So in this case, the domain, all real numbers, because it always is. The range is y is less than or equal to -3. Make sure you put the less than or equal to or greater than or equal to. All right? So find the domain and range for these two. One other part of quadratic functions that's very important is where they cross the x-axis, so what we call the zero of a function. Right? You'll notice on this bridge up here in this picture that they show different parabolas are drawn there, and there's two important parts that we look at for zeros. One of them would be here, where the graph crosses the bridge. That's an important part. But also, if it continues on like this one does, it's also important then where that's going to hit the water. All right? So when they're talking about the strength of them and like that. I saw a picture the other day of someone on top of the Mackinac Bridge. My brother-in-law, he lives up that direction, and his wife works at the bridge, and he was able to go up to the top of the Mackinac Bridge. So they actually have an elevator that goes up there. So that was pretty cool. All right. But when we talk about zeros, we're just talking about when does the graph cross the x-axis. And with a quadratic function, it could not happen at all sometimes. There are no zeros. Sometimes there's only one zero. Sometimes there's two zeros. So you could have 1, 2, or no zeros with a quadratic function. But all we want to know is when does it cross or touch the x-axis. So look at these three graphs and tell where they cross or touch the x-axis if they do at all. And those are the zeros of the graph. All right, so for letter A, this graph crosses the x-axis in two places. All right, so we say that the zeros are at -1 and +3. All right, where they cross the x-axis. For letter B, it intersects the x-axis here at -4, so we say there's just one zero, and that's at -4. All right, we're not going to say x equals. We're just going to say these are what the zeros are. Now, if we were solving an equation, then we would say x equals. All right, but right now we're just saying that. And then in letter C, since the graph never crosses the x-axis, there are no zeros. And what we're going to be doing later on is one of the really important parts of algebra is finding zeros for quadratic functions. And we will be learning all the different ways of doing that in this chapter. One is by looking at a graph. You could do it by a table. We will be factoring to find zeros. And then we'll be doing something called the quadratic formula and completing the square. All right? All right. So last thing, all right, graphing. All right. When we're graphing, to graph a quadratic function without using our calculator, all right, we need a couple of things. We need the vertex, which we have to find the axis of symmetry first to find the vertex. We need to know the y-intercept, so we'll talk about what the y-intercept is. It's a little bit more. You worked on that yesterday. And then we're going to need one more point on the opposite side of the axis of symmetry from the y-intercept. So we have this equation, y equals 3x squared minus 6x plus 1, and we want to graph it. So first thing I'm going to do is label my a, b, and c. A is 3, b is negative 6, c is 1. Now, as you're doing this, you should be thinking about a couple different things while you're doing it. Is first of all, when I look at that, the first thing I say, if I'm going to graph it, the first thing I want to know is which way it opens. All right? So does this one open up or does it open down? Okay, this opens up because A is positive. Okay? Since A is positive, it's going to open up. That means that when I do graph it, I better make sure that my graph opens up. All right? Because if it doesn't, then I made a mistake. All right, so we find our axis of symmetry. X equals negative b over 2 times a. Oops. All right, so, oh, this is nice. We have 2 negatives. That's a positive, so we get 6 over 6, which is 1. All right, so our x value for our vertex, the axis of symmetry, is at 1. So to find the y value, we plug that in. All right, now always remember your order of operations. So we square this 1 before we multiply by 3. So we get this equals 3 minus 6 plus 1, which is negative 2. All right, so the vertex is at the point 1, negative 2. All right, so I can graph that. 1, negative 2. There's my vertex. Okay. So the next thing I need is the y-intercept. What's the y-intercept? Jenny? C. Okay, the value of c is the y-intercept, so my y-intercept in this case is 1. Okay, so that means on the y-axis, the graph intersects the y-axis at positive 1. So here's the thing about a quadratic. Since it's symmetrical and it's cut in half by the axis of symmetry, so the axis of symmetry would be right here. All right. Since from that axis of symmetry I go 1 to the left to get to the y-intercept, I'm going to go 1 to the right of that point to get a third point that I need so I can draw my graph. And make sure it's a curve down here. It doesn't come to a point. It's not a V, it's a U. Okay? All right, so when you're graphing it, we need to know the vertex. So we have to find the axis of symmetry. We need the y-intercept. And then we need a point across from the y-intercept, across the axis of symmetry from the y-intercept. But when you graph them, you're not going to put the axis of symmetry there. So you might just draw it in real lightly to be able to get that other point you want, but then make sure you erase it afterwards. Okay? All right.